One of the many open mysteries about spiral galaxies is how they attain their present-day magnetic fields. These have been observed to have typical strengths for their large-scale component on the order of microgauss. In case the primordial magnetic field of our universe happened to be extremely weak, a possibility to amplify it up to the values observed in galaxies these days is through a turbulent dynamo. This dynamo mechanism is based on the chaotic motion of turbulence that winds up magnetic field lines, stretching them and therefore increasing their spatial density. This in turn amplifies the magnetic field. Due to the presence of turbulence in the interstellar medium of galaxies, this mechanism is one of the potential candidates to generate the observed magnetic fields. This turbulent dynamo has been shown to operate in numerical simulations of isolated spiral galaxies by Michael Reeder and Roman Tessier in a 2016 publication. In order to fully understand how it functions, given a realistic evolution of a spiral galaxy, we now study how magnetic fields evolve in one of these galaxies, simulated fully submerged in a cosmological environment. By doing so, we can also assess how cosmological effects influence the evolution of the magnetic component of this galaxy. Our simulations are generated with the adaptive mesh refinement magnetohydrodynamical code RAMSES, which employs a constraint transport algorithm to solve the magnetic component. This is particularly important as employing this method maintains the divergence of the magnetic field exactly equal to 0, down to numerical precision, really fulfilling now the solenoidal constraint. Our simulations portray a cosmological box, with a zoom region where AMR scheme is allowed to generate better spatial resolutions, down to 10 spatial parsecs. It is in this region where the galaxy will form, and this resolution allows us in turn to capture the turbulence inside it. Focusing on 3 specific runs, 2 with different feedback prescriptions in green and in blue, and 1 with no feedback in red, we study amongst various other things the evolution of the specific magnetic energy in the region of the galaxy. We observe this quantity to evolve in 3 main phases. A first one, during which its evolution is governed by the collapse of the primordial perturbation that gives birth to the galaxy. A second one, when the galaxy evolves through cold accretion, with the turbulence in its ISM governed by this accretion. During this phase, we find some turbulent amplification to occur, independently of the feedback prescription but dependent on the resolution. It is at the later stage, after the galaxy forms a rotationally supported disk, when the evolution of the specific magnetic energy is found to depend on the feedback prescription employed. Now amplification only occurs in the presence of stellar feedback. If you are interested in the topic, take a look at our paper. Feel free to also contact me with any questions you may have. You can find my contact details and a link to the paper on my webpage. And thanks for watching.